Okay, on this problem, you can read all these words, but basically they have this tower. Here's this tower. It's got, there's this tower right here. I think it's this tower that's on the side of a mountain, right? So we have this mountain right here. This tower is on the side of the mountain, and they um have this, what's it called, a guy wire, this wire going down the hill, this wire down the hill, and they're attaching it to kind of secure the tower. And that is 162 yards down the hill is where they attach the guy wire. And the guy wire is at an angle of 24 degrees. The hill's at an angle of 56 degrees. The question is, how long is the guy wire? So let's wire, we'll call this X. That's what they want to know, right? Find the length of the cable, the wire, the cable, whatever you want to call it, right there. Find that dotted line. How long is that? Okay. So to do this problem, let me show you what we do. So what you want to do is you want to extend some of the lines. Specifically, let's bring this line straight over and this line straight down. I know that can be kind of confusing. You can draw a line right through the middle of the tower like that, because that's the middle, that's the height of the tower, whatever, it doesn't matter. So I just extended those things, okay? Now, why am I doing that? Well, because I want to find some angles. Let me show you what I mean. I made this a right angle right here. Right, you can, if I want to get that over, you can tell that's where I just brought it. You think, how do you know? Well, I just brought this tower. I just extended the tower. The tower stops right there on the hillside. I said, what if we just let it go straight down and bring this side straight over to make a 90-degree angle? I want to make a right triangle because I can do stuff with right triangles. Okay. Now, look at this 56-degree angle. Do you realize this is going to be the same thing? How do you know? Well, because it has a flat and then the hill, flat and then the hill. See how they have to be the same? Flat and hill. And I brought this flat on purpose and this straight down to make a 90. So this is flat like this is, and this is the hill. So whatever angle the hill makes with flat, 56 degrees, so the hill makes with flat, 56 degrees. So this has to be 56 degrees also, right? Okay, so what? Well, then that means if that's 56, then what? Let me see. Then I know this entire angle right here, it's got to be 56 degrees plus 24 degrees, right? And that's 80 degrees. So that's got to be 80 degrees. This whole thing, 80 degrees, that whole angle there. Okay, so what? Well, and I know this, as I said, I know this is 90. And every triangle holds 180. So now I can get this angle up here, right? Because 80 degrees plus 90 degrees is 170. And the whole triangle holds 180. So take away from 180, this angle up here must be 10 degrees. See what I'm doing? So again, what did I brought this straight over and let the tower go straight down. So I'm extending the tower, made a right triangle, right angle here. Okay. This is 56 because it's the hill with the horizontal. So this is also 56. It's the hill with the horizontal. 56 and 24 makes 80. This is 90. This must be 10 to make 180 in the triangle. Okay. So now what can we do? Well, now that we know that angle up there is 10, that's why that's so important to get that angle, is 10. Now I can kind of get rid of the extension and go, oh, so if this angle is 10 and this is 24, then I can find this right here, because 10 degrees. Now I'm changing my focus. Now I'm focusing. Let me show you. I should try to be more clear. Now I'm just dealing with this triangle. Forget about the extension. I just extended the right triangle a minute ago just so I could find this angle up here. That was my whole purpose. I want to find this angle. But now I'm done with that. Now let me go back to just this triangle. I go, oh, this is 10, this is 24. I can find this angle, right? Because the three angles in any triangle always total 180. So if you add those two up, get 34 degrees, take that away from 180, you get 146. Okay, so this is 146 degrees right there. Now I can do law of sines. Do you see it? Why did I do all that work? Because I wanted to get this angle and I wanted to get this angle. Now, remember, you can use law of sines whenever you know a side. Say, I know this is 162 degrees, 162 yards, how far down the hill where the guy wire is attached. And this is the angle across from it, 10 degrees. So whenever you have a side and the angle across from it, you can use law of sines. Remember, that's how we know we're going to use law of sines on this one and not law of cosines. Law of sines is easier. We would prefer to use law of sines if we can. When can we? So let me write it up here to be super clear. When you have a side and opposite angle, use law of sines. So that's the deal. Whenever you have a side and the opposite, oh, I didn't write angle. There we go. When you have a side and the opposite angle, use the law of sines. And I have 10 degrees and the angle and the side opposite 162, and then I can match that up with these two, and I can find my x. You see. Oops. Okay, so let's go back to it. Looks like I can picture. I don't know why it's doing that. There we go. It's better. Okay. Anyway, let's do law of sines now. So law of sines, I come down here and I'm going to say, okay, so these two and these two. Remember, law of sines is always about angles and the sides opposite them. So I'm going to go x over the sine of 146 degrees, right? These two is equal to these two. Start with, I'm going to put the signs on the bottom, or you can put them on the top. It doesn't matter. Okay, I'm a little tired of that. Okay, so sine of 10 degrees. I just keep shifting this diagram. Okay. All right, so there's my setup. Sorry, the picture got a little messed up there. All right, so there it is. Trying to fix that picture. I don't know how to do it. I don't know why it keeps doing that. So now I'm going to solve this by diagonal on that. And so I've got x sine of 10 degrees is 162 sine of 146. Get this stuff here. And I can solve for x. Just divide by the sine of 10 degrees. Boom. Hit the buttons on your calculator and you will get that answer right there. So there it is. Oh, wait. Trying to fix this thing here. Well, it's the best I can do. There, that's better. Okay, so now it fits again. Anyway, so do you see what I did there? So one more time, let me run over the whole thing real quick. Hopefully not mess up the picture again. So basically, I extended the triangle straight down and straight over to make a right triangle so I could find all the angles. Remember that? And this is 56 because it's the hill with the horizontal. So this is 56. So then I knew this whole thing was 80. And this is 90. So I could find this is 10 because every triangle has told 180. Once I knew that was 10, I got rid of the extension and then just dealt with this and said, well, this is 24, this is 10. I could find this angle right over here, found it 146. Then when I had all three angles, I knew I could use law of sines because you can use law of sines whenever you have a side in the opposite angle. So I had X, which I'm looking for, and the opposite angle, 146 now, 10 and 162. I set up law of sines right here. And with law signs, you can put the signs on the top or the bottom. You just have to be consistent. I put them both on the bottom. You could flip this over and flip this over and put both the signs on the top. Just be consistent. It doesn't matter. When you do the diagonal cross multiply, it'll work out the same either way. And there's our answer for X. There we go.